Tree diagram. A tree diagram is a visual representation of the possible outcomes of an event and their associated probabilities. It is a useful tool for calculating the probability of complex events that involve multiple stages or components. The diagram is composed of nodes and branches that represent the different possible outcomes and the probabilities associated with each outcome, respectively. To draw a probability tree diagram, follow these steps. Start with a single node at the top of the page, representing the initial event or decision. Draw lines extending downward from the central node to represent the different possible outcomes of that event or decision. Label each branch with the probability of the associated outcome. Add additional nodes and branches as necessary to represent subsequent events or decisions and their associated probabilities. Continue this process until you have represented all possible outcomes and associated probabilities. Then calculate the probability of each final outcome by multiplying the probabilities along the branches that led to that outcome. Review the probability tree diagram to ensure it accurately represents the event and associated probabilities. Here is an example of a simple probability tree diagram. Suppose you are flipping a coin twice and you want to know the probability of getting 2 heads. Here, the coin first toss for head it will be 1/2 and for tail it will be 1/2. Then for second toss, probability for head will be 1/2 and probability for tail is 1/2. Similarly, for this point, probability for head is 1/2 and probability for tail is 1/2. Now outcome will be head, probability is 1/4. For this, outcome will be head and tail and probability is 1/4. Similarly for tail head and for tail tail. In this example, the initial event is flipping a coin and there are 2 possible outcomes, heads or tails, each with a probability of 0.5 or 1/2. We then repeat this event, resulting in a total of 4 possible outcomes. The probability of getting 2 heads is the probability of following the branch head on the first coin flip and then following the branch H on the second coin flip, which is 0.5 times 0.5 equals 0.25. Examination tips. Once the tree diagram has been created, you may use it to determine the likelihood of particular events. Multiply the probabilities along the branches that led to a result in order to determine its likelihood. Worked example. On any Saturday, the probability that Arun plays football is 3/4. On any Saturday, the probability that Bob plays football is 2/5. Complete the tree diagram. The probabilities of all possible outcomes of an event add up to 1. As the probability that Arun plays football is 3/4, the only other option is that Arun does not play. So the probability will be 1 minus 3/4 equals 1/4 for Arun does not play. Then the probability that Bob plays football is 2/5. The only other option is that Bob does not play. So the probability will be 1 minus 2/5 equals 3/5 for Bob does not play. So the probability that Bob plays is not affected by whether or not Arun plays football. So it will be like this. For Arun plays 3/4, does not play will be 1/4. And for Bob plays 2/5, does not play will be 3/5. Now calculate the probability that one Saturday Arun and Bob both play football. To find this probability, identify the route on the diagram and multiply the probabilities of each event together. Arun and Bob both play football. So both plays football will be here. 3/4 times 2/5 equals 6/20. Calculate the probability that one Saturday either Arun plays football or Bob plays football, but not both. To find the probability that only one of them plays, identify the possible routes. One of them play and the other does not. So it will be 3/4 times 3/5 or 1/4 times 2/5. So find the probability of each route by multiplying the probabilities of each event together. Arun plays but Bob does not play is 3/4 times 3/5 equals 9/20. Arun does not play but Bob plays. So 1/4 times 2/5 equals 2/20. To find the probability that only one of them play, add the above calculated probabilities together. So it will be 9/20 plus 2/20 equals 11/20. Test yourself. Question number 1. A bag contains 15 red beads and 10 yellow beads. Ariana picks a bead at random, records its color and replaces it in the bag. She then picks another bead at random. Find the probability that she picks 2 red beads. It's a true mark question. Find the probability that she does not pick 2 red beads. It's a true mark question. Question number 2. Tanya plants some seeds. The probability that a seed will produce flowers is 0.8. When a seed produces flowers, the probability that the flowers are red is 0.6 and the probability that the flowers are yellow is 0.3. Complete the tree diagram. It's a true mark question. Find the probability that a seed chosen at random produces red flowers. It's a true mark question. Tanya chooses a seed at random. Find the probability that this seed does not produce yellow flowers. It's a 3 mark question. Question number 3. 40 children were asked if they have a computer or a phone or both. The Venn diagram shows the results. A child is chosen at random from the children who have a computer. Write down the probability that this child also has a phone. It's a 1 mark question. Question number 4. Box A and box B each contain blue and green pens only. Raphael picks a pen at random from box A and Paulo picks a pen at random from box B. The probability that Raphael picks a blue pen is 2/3. The probability that both Raphael and Paulo picks a blue pen is 8/15. Find the probability that Paulo picks a blue pen. It's a true mark question. Find the probability that both Raphael and Paulo picks a green pen. It's a 3 mark question. Question number 5. The probability that it will rain tomorrow is 5/8. If it rains, the probability that Raphael walks to school is 1/6. If it does not rain, the probability that Raphael walks to school is 7 over 10. Complete the tree diagram. It's a 3-mark question. Calculate the probability that it will rain tomorrow and Raphael walks to school. It's a 2-mark question.